Come sit by Sam. I can see you there. All right, last class we were talking about something called ionic compounds. Ionic compounds. Tim, can you tell me what an ionic compound is?
An ionic compound is when two ions come together.
Okay, that's very correct. That's a nice simple explanation.
A metal and
Two ions come together. That's right. A metal and a non-metal can come together in ionic compounds. Okay? What's that? Hydrogen's lonely, yes. Metal and a non-metal. Sit up, Sim. So, if I had a metal, let's say this metal right here, strontium, okay? And strontium was combined with, let's see, what are we going to combine it with? Here it is, ready? Which one is the metal? Which one is the metal? Strontium or iodine? Strontium's the metal. What number is it? Can anybody find it?
38.
38. All right. So iodine must be the what? Non-metal. What number is iodine? 53. All right. So strontium and iodine are coming together. And because it's a metal and a non-metal, we know that this is going to be an ionic compound. Correct? What is strontium going to want to do? Lose two electrons. If you lose 2 electrons, what kind of little symbol do we have to put up here to show that you've lost 2 electrons?
Oh.
What do we have to put up here to show that you've
Plus.
lost 2? Plus what?
2.
2. You have to put the 2 in there because you've lost 2 electrons. Okay? What does iodine want to do
Plus
to
1.
become noble?
Oh, I know what you're going to do.
Gain 1 electron. So what's the charge going to be?
So it's minus 1.
Minus charge like that. Minus 1
And then
charge.
you need to have 2 iodines.
Okay. So it's going to be strontium, iodide. And where does the 2 go?
At the bottom.
At the bottom after the iodide. Right? Very good. So this is an ionic compound. Now, if I take this ionic compound, here's a pile of it right here, and there's the bowl that it's sitting in. There's the pile of ionic compound right there. If I take that compound and put it into this container of water, will it dissolve in the water?
Yeah.
Well, is it soluble in water? That's the question now.
Yes. Yes.
You sure? No.
No.
We have to use the things that we learned about solubility.
Is it going to be the 7th row?
All right, because iodine is in the 7th row,
Alright.
then what? It is soluble. That's right. So, when we have an ionic compound that does dissolve in water, once it dissolves in water, it breaks up into what? And this was the miracle that we learned last class. It breaks up into S, R, plus 2, and I minus. It breaks up into its ions. Okay? And to show that these are dissolved in water, you write AQ, like that. Aqueous. Alright? Ionic compounds that are soluble in water break up into their ions. Alright, let's try one more. Okay, here we go. P, B, we'll start up here. P, B, and B, R. P, B, and B, R. P, B, and B, R.
Bromine and iron.
Why don't you come sit over on the couch? Make some room for the people on. Or maybe I should move over here a little bit so the people on the couch. Okay, we're trying to find out how these compounds come, or how these elements come together to form a compound. How do these elements come together to form a compound?
We gotta see. Lead wants 4. Bromine wants 1.
Wait, where's lead? What's the number?
82.
P. I found PB.
Me too.
Right there. I found the
Yeah,
lead.
it's not gonna work out.
Need a bunch of losers.
I found
RB, but not
Isn't this a
BR.
problem that they both want more?
Okay. Actually, the staircase separates the what?
Metals and non-metals.
Metals and nonmetals. Metals always want to lose electrons.
Where's PB?
Metals always lose electrons. Nonmetals always want to gain electrons when you're forming an ionic compound.
Okay, wait, when it passes through the green, we have to count all of those.
Passes through the what?
Where's BR?
No.
I found RB.
So we're learning something here. We've
What's
learned
82
something.
minus 54?
No. Don't do that, Tim. Don't worry about it. We're learning that when a compound is formed between a metal, like lead, that's way over on the other side,
Oh, found BR.
we can't just count the number of electrons to determine how many it loses. Lead wants to lose 2 electrons. Lead wants to lose 2 electrons.
I found PB.
Well, it's a
and
complicated answer, and we won't be able to answer that anytime soon.
Come on.
But for now, lead wants to lose 2 electrons, Tom. So what kind of a charge is lead going to have?
Negative.
PV plus
Positive.
2.
Plus 2. Plus 2. How do you know plus 2?
Because that
Oh,
means
there's 2 birds.
Plus 2. Now, why does plus 2 mean losing 2 electrons?
Because
That's confusing.
electrons is negatively charged.
Okay, electrons are negatively charged. So if you lose 2 negative charges, you get a net, or in other words, which means a resulting positive 2 charge. Where's that positive 2 charge come from?
BR.
It comes from the protons that are in the nucleus, right? So you've taken away 2 electrons, and now there's 2 protons that don't have electrons to
What?
cancel them out.
This is all their electrons.
Then it would be PB with a positive charge of what?
82.
82. That's right.
But I mean, what happens?
Well, it's extremely unstable, right? It'd be very hard to keep electrons away from something like that, right? Because we pull them from anywhere it could.
Okay,
All right, BR wants to do what?
minus 1.
Minus 1. Because it wants to take on 1 electron, right, Emma? How did you know it wanted to take 1 electron?
Because
BR. How did you know BR wanted to have a negative 1 charge? First, we have to find it on the periodic table, right? Did you guys find BR on the periodic table?
I found it.
And then we can, because it's a non-metal, we can count how many away it needs, or how many boxes away it is from the noble gases, correct?
We need 2 bromides.
All right. So the resulting compound is going to be PB,
PB.
BR,
2.
2 bromines
I found
for every
both
lead.
of
Correct?
Yeah.
Very good. Now, if I have a pile of lead bromide, here's my pile, and I put it into a cup of water, correct? Here's my cup of water. I put it in there. Is it going to dissolve?
Yes, it's in group 7. Well, wasn't there some exceptions? For
There was some exceptions. Is this one of those exceptions? Anybody have it written down in a book?
Yes, it's an exception.
How do you know?
Nathan
What?
has. Nathan's writing.
Do you have anything in your book about group 7s? No? Do you have anything, Nathan, about group 7s? When we were talking about things that are soluble?
I think so.
Is
Go, Sam.
the rules for solubility.
It has to. Is it this? Right here?
Try the next page. Oh, the page the other way. The other way.
Oh.
Not- Try the next page. Is that it? Is that the last page?
No.
I'm pretty sure lead was one that it was.
That's right. Lead is one of the exceptions. Lead, mercury, and silver. Lead, mercury, and silver are all the ones that are not soluble, even with group 7.
Are they never soluble unless they're with one?
Group lead, mercury,
Yeah.
and silver.
Yeah.
They're soluble if they're with nitrates, remember, or sulfates, or
Well, group ones.
well, group 1 is another metal, so they're already a metal, so they're not.
Alkali metal.
What Dad, what if they were with like sodium?
Lead and sodium wouldn't come together because lead wants to be a positive charge and sodium wants to be a positive charge. Does that make sense? You have to make a metal from in a non-metal to make an ionic compound. All right, you see how that works? Ionic compounds that dissolve in water split into their what?
Groups.
Separate into ions. Ions. One more example. Doesn't sound like we caught it. Na, here it is. Cl. Is that the right way?
No.
NaCl. It is soluble in water, so when we put it into water, it breaks up into what?
Ions.
Ions, which are what? In this case, what are they going to be?
Oh, Na and NaCI. AQ.
What's the charge on the Na?
Plus.
Na wants one.
Plus
No.
1, because sodium wants 1, or wants to give up 1.
Wants to give
And
one.
Cl,
Chlorine. Oh yeah, chlorine wants negative.
negative.
Minus.
That's right. So, this is a solid.
But they would stay together.
This is a solid, but if you put it into water, they're going to separate.
Wait, that's not a solid, Dad. Is
Yeah, sodium chloride.
aqueous.
It can be a solid, but as soon as you put it into water, it separates into sodium ions and chloride. Sodium chloride?
Oh, I thought. Yes,
No.
it's in the first salt. It's in the
Oh,
first row.
that's right. Anytime there's water around, it's not solid. That means that it dissolves in water. It doesn't mean that it has to be a liquid. It just means that it dissolves in water, right?
Because you can
Because
melt
yes,
it.
well, you can
Could you
have
melt it?
Yes, you could. You can have a tray. Here's my tray, and I have some solid sodium chloride on it, and then I can put it into some water, right? Sodium chloride is just salt that we have on our table, pretty much. Okay. All right. So those are what we call ionic compounds. Why do we call them ionic compounds?
Because they have ions in one.
Because they're made of ions. Now, that's it for today. So, I have a challenge for us. We started 1 minute late, and a lot of people showed up late. If we show up on time, then we'll get in that extra couple minutes that we missed. All right?
It's 8:15.
It's 8:15. Time to go play. Go play. Go, 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 go. Have a great day. Read your periodic tables.
Yeah, Tim.